I want to start working on some new projects, but if I'm going to do that, I'm going to need some bench equipment first. So I'm going to make a new video series about making my own simple bench equipment, and I figured a power supply would be a good place to start. So I'm going to be using this old 500 watt ATX PC power supply, and I'm going to turn it into a bench supply. This is a pretty common project, and I'll post some links to some other ATX power supply builds down below. But I think the reason this is such a popular project is because, one, these power supplies are so easy to get, and also most of the work is already done. Right here on this connector, it already has a whole bunch of different power supply outputs, along with some controls and indicators. As for power supply outputs, all the black wires are ground. The red wires are all 5 volts, which is useful for a lot of projects, especially projects that use TTL. The orange wires are plus 3.3 volts, which is pretty useful for a lot of CMOS circuits. The yellow wire is plus 12 volts, which could be useful for just about anything. The blue wire here is a minus 12 volt power supply to go along with that plus 12 volt one. And my power supply here is a little bit special in that it has this white wire here, which is a minus 5 volt rail. The minus 5 volt wire was optional in the ATX standard, so really the only power supplies you'll see that have this minus 5 volt wire are some really old power supplies. And most newer power supplies just won't even have this white wire. And as for controls and indicators, there's this little green wire here that when connected to ground will take the power supply out of standby mode. So that's our power on wire. I jammed a little toggle switch in here from when I was using this for some other projects. So when I flip this switch, it connects this green wire to one of the ground pins next to it and powers up the supply. The purple wire is the standby wire. So even when the power supply is not fully powered up and it's in standby mode, this wire will have 5 volts on it, which is just an indicator that it's plugged in and turned on. And this gray wire here is a power good indicator. So if it's not in standby mode and it's actually powered on, then this gray wire here will be powered up. And if it's in standby, or if something goes wrong and the power supply has to shut itself off, that will go down. So that's a nice indicator of whether or not everything is functioning right. So most of what I have to do is just breaking out all these voltage rails to some binding posts so I can put wires on them, and putting some LEDs on these indicators, putting a proper switch on it somewhere, and putting it all in a nice looking box. But there is one other thing that I would like to do, and that is give this power supply a floating ground. Pretty much all bench supplies that you'll buy will have floating grounds in the output rails, but not these ATX supplies. And when I say the ATX supply does not have a floating ground, what I mean is that the ground rail at the output of the power supply is connected directly to the ground rail of the electrical outlet, which is that third prong. Now that might sound like something that we would want, and in some cases it is, but in a lot of cases it will create what's called a ground loop, which is, well, just a loop in the ground path. For instance, if I had my circuit connected to my power supply and also to my oscope or computer, there are 2 different ways that my circuit would be connected directly to that ground prong in the outlet. And there are a few ways this could cause problems. For one, this big loop here might act as an antenna and pick up radio, which I don't want in my circuit. Also, this loop could act as the secondary winding in a transformer, with the entire room acting as the primary winding, and I could get some 60 Hz hum into my circuit that way. And another thing to keep in mind is that if something else plugged into that same wall circuit ends up dropping some current onto this ground wire, then on its way back to ground, it sees not just one path, but 2 paths that it could take to get back to ground. So that current is going to take both of those paths, and one of them leads right through my circuit. Now keep in mind this third wire here is supposed to be an emergency return path. It's not normally supposed to have current on it, which means that if there is current flowing on here, something has gone wrong, and I really don't want to have that current flowing through my circuit. So for instance, if I rub my feet on the carpet and then touch my toaster, that static electric discharge needs someplace to go, and it goes through the case and to ground through that wire in the wall. But now some of it is going to be going through my circuit as well, which I don't want. And also, if I drop my toaster in the bathtub again, I might end up with a direct connection from the hot wire directly to the ground wire. So now I would have a huge amount of current flowing through that ground wire, which again would also take this path through my circuit. Or also, if these two devices are far enough apart, or if they're on different electrical circuits in my wall, then the grounds might actually be at different voltages, and I might end up with some pretty unfriendly DC voltage across my circuit through that ground wire. And I can solve all of these problems just by isolating the ground at the output of my power supply, right here. So my circuit is still connected to ground through the oscope or the computer, but now since there's only one path to ground, I don't have that loop there, so there's no antenna to pick up radio or 60 Hz hum. There's no emergency return path to ground, and if these two grounds are at different voltages, it no longer matters because they're not connected together anymore. So this is roughly what I expect the power supply to look like on the inside. The hot and neutral lines are going to be connected to a transformer which steps the voltage down. That will go to a rectifier which converts AC to DC, and then from there it goes into some switching regulators which generate the voltages that I need at my outputs. There's probably also going to be a small linear regulator in there to drive some control circuitry, which controls the power up and standby modes and the overheating protection and all that for these switching regulators. And the third prong of the outlet, which is ground, is going to be connected directly to the metal case. Now, all of the circuitry inside here probably shares a single ground, and that is also going to be connected directly to the case, and through the case will be connected to the ground prong. So hopefully all I should have to do is lift the circuit board off of the case, and that should break this connection, and then I should have an isolated ground. So now, just to show what's going on here, I have one end of the multimeter clipped onto the ground of one of the output rails, and the other end of the multimeter clipped onto the third prong on the plug there. And you can see really low resistance. It's basically shorted together. So now let's open it up and see if we can't break that circuit there. If you want to open up one of your own, make sure it's unplugged and been powered off for a while. There will be some big capacitors in there that might still hold a charge on them for a while, and you don't want to get shocked when you touch something in there. You'll probably be fine though. So now let's open this up. Let's unplug the fan, get this out of here. So in mine, the board is held down by 4 screws on the corners, so we gotta take those out. And there we go. Now I can sort of lift the board just a little bit. So now I've got the multimeter hooked up between the third prong and one of the ground rails again. I'll put it in beep mode so that you can hear if it breaks the circuit when I lift it off. So it looks like the only connection between the ground rail and the third prong is made through the case. So if I just put some maybe some plastic washers and screws in there, or maybe just take the board out entirely, I should be able to get an isolated ground output. Another thing to remember if you're doing a project like this is that switching converters usually, in general, need some minimum load attached to them in order to regulate properly. For the 12-volt rails, the fans that are in the power supply are usually good enough dummy load. For the 5-volt rail, some power supplies, especially older power supplies, might not have a dummy load in them, and might have just relied on the computer that they're plugged into to be the load. Most newer power supplies, and looks like that includes this one, have a built-in 10 ohm dummy load on the 5-volt rail. So if your power supply does not have some kind of load between 5-volt rail and ground, then you're going to have to add one externally. So that's it for this video. All I really should need to do is just lift the board out, find a nice box to put it in, and then get some banana plugs for it. That should get me up and running. It's probably a good idea to eventually add some protection to it so I don't blow up whatever circuit I have plugged into it. Maybe some fuses or something, but I don't really care about that right now.